Hello there, and welcome to the Sleepy Science Channel. Tonight, we are exploring something that's with you every moment of every day, yet you may rarely pause to consider it. Health is the living system unfolding inside you right now. Your heart adjusting its rhythm, your lungs trading breath for energy, and every one of your tiny cells in a constant state of repair and renewal. Beneath your awareness, an orchestra of chemistry and electricity keeps you upright, thinking, feeling, healing. What if the ordinary sensations of your day were part of something vast and intricate? What if small choices ripple through networks of tissue and time, shaping how you will feel years from now? Health is not a single organ or a single habit. It is connection. It is adaptation. It is resilience written in flesh and thought. If you enjoy these gentle journeys, I invite you to like, subscribe, or share a thought below. It helps others find their way here too, one sleepy soul at a time. But for now, all you need to do is relax. Let your shoulders soften and allow your breathing to slow. And allow your mind to gently unwind as we wander through these hidden systems together. Let's begin. Your immune system learns, remembers, and adapts after almost every infection. After you recover, parts of your defense system do not simply stand down. They keep records. Special cells store patterns of what they encountered, so a second meeting can trigger a faster, sharper response. That is why many childhood infections rarely return in the same way. It is also why vaccines can protect you without forcing you through the full illness. This learning is not only about brute strength. It is about precision, like swapping a wide net for a tailored key. Over time, your body builds a personal library of microscopic mugshots. That library changes with age, travel, seasons, and even the people you live with. Health, in this sense, is partly a story of experience. Your immune system carries that story forward. A few minutes of movement can shift your blood sugar. When your muscles contract, they can pull glucose out of the bloodstream for fuel, even before your body leans heavily on insulin. This is why a short walk after a meal can change what happens in the next hour. Instead of glucose lingering and spiking, more of it gets guided into working muscle, where it can be burned or stored for later. It is a fast, practical form of chemistry. You do not need a marathon to see the effect. Climbing stairs, pacing during a phone call, or doing a handful of sit-to-stands can nudge the curve. Over days and weeks, this repeated signal can make cells respond better to insulin, which lowers strain on the pancreas. Movement is not only fitness. It is real-time blood chemistry you can influence. Sleep changes hormone signals that shape appetite the next day. A short night can tilt the chemistry of hunger before breakfast even starts. With less sleep, the body often raises signals that increase appetite and lowers signals that help you feel satisfied. The result can be cravings that feel strangely urgent, especially for calorie-dense foods. It is not a character flaw. It is biology trying to solve an energy problem. Sleep loss can also make the brain's reward circuits more responsive, so treats look more appealing and self-control feels more expensive. Add a busy day, and it becomes easy to eat past comfort without noticing. Over time, this pattern can push weight and blood sugar in the wrong direction. Sleep is not only rest. It is metabolic planning. When you protect it, you are not just avoiding fatigue. You are helping your body set tomorrow's appetite to a steadier setting. Relaxation can lower muscle tension, which can reduce some pain cycles. Tension is a form of holding, and the body can learn it as a habit. Jaw clenching, raised shoulders, shallow breathing, and guarded posture can keep muscles partially contracted for hours. That constant load can reduce blood flow, increase irritation, and trigger headaches or neck pain in some people. Relaxation techniques work partly by changing that baseline. Slow exhalations can cue the nervous system to downshift. Progressive muscle relaxation teaches you to notice tension, then release it deliberately. Warmth can help by improving circulation and signaling safety to the brain. Even brief breaks in posture can matter, like standing up, rolling the shoulders, or unclenching the tongue from the roof of the mouth. This is not about pretending pain is mental. It is about removing a contributor that often rides along with stress and fatigue. When tension drops, pain signals can become less intense, and the body gets room to recover. Your gut microbes help train immune cells and tune inflammation. Inside the folds of your intestines, microbes live close enough to matter, yet usually far enough to stay harmless. Your body treats them like neighbors, not invaders, and that relationship shapes how your defenses react. When the balance is steady, immune cells learn restraint as well as readiness. When the balance is disrupted, signals can tilt toward inflammation. Some microbes break down fiber into compounds that help the gut lining stay strong, which matters because that lining is a major gate between the outside world and your bloodstream. Diet changes can shift this community in days, which is astonishing given how personal it is. Antibiotics can also reshape it, sometimes temporarily and sometimes longer. Your microbiome is not just along for the ride. It is part of how your body decides what is safe. Stress hormones can change how fast wounds close and seal. When the body senses threat, it releases hormones that are useful in emergencies, yet costly when they stay high. Cortisol and related stress signals can shift the immune response and slow the early steps of repair. In studies, people under heavy ongoing stress have shown slower healing of small, controlled skin wounds compared with less stressed participants. The difference is not magic, it is resource allocation. The body prioritizes survival readiness over long-term rebuilding. Stress can also disrupt sleep, and sleep is a time when repair signals rise. That is a double hit. This does not mean stress dooms healing. It means recovery improves when the body gets clear messages of safety. Supportive relationships, time outdoors, calming breathing, and steady nutrition can help. Wound healing is one of the clearest places where mind and body meet, then leave fingerprints you can measure. The placebo effect can measurably change pain, nausea, and tremor. Expectation is not only a thought, it can be a biological instruction. When someone believes a treatment will help, the brain can release its own pain-dampening chemicals and change how signals are processed in the spinal cord and cortex. That can alter real symptoms, including nausea, itch, and fatigue. In Parkinson's disease research, placebo responses have been linked to measurable dopamine release, which can briefly improve movement. This effect does not mean symptoms were fake. It means the brain has built-in controls that can turn volume up or down based on context, trust, and prediction. It is also why the opposite effect exists. If people expect harm, symptoms can worsen, even with an inert pill. Medicine takes this seriously. Clinical trials use placebos to separate chemistry from expectation. Your brain is part of every treatment, whether the treatment is a drug, a ritual, or a reassuring voice. Your brain predicts body needs, then adjusts breathing and heart rate. Much of your body regulation is proactive, not reactive. The brain constantly guesses what you will need next, then adjusts circulation and breathing in advance. Stand up, and your heart rate rises before you faint, because pressure sensors and prediction circuits coordinate a quick response. Start a run, and breathing deepens because the brain expects carbon dioxide to climb. Even anticipation can shift the system. Thinking about a stressful conversation can change heart rhythm before a word is spoken. This is part of a broader strategy called allostasis, which means staying stable through change. The benefit is speed. The risk is overshoot. If the brain predicts danger too often, the body lives in a higher gear than it needs. Practices like slow exhalations, paced walking, and steady routines can retrain those predictions. Health is partly about helping your brain feel safe enough to stop bracing. Small routines compound, and health becomes a long, quiet math problem. The body responds to what happens repeatedly, not only to what happens once. A single salad does not transform you, and a single dessert does not undo you. The compounding comes from patterns that slowly tilt your baseline. A nightly wind-down routine can improve sleep quality, which affects appetite, mood, and focus. A short walk most days can change how muscles handle glucose and how the heart handles effort. Brushing and flossing can lower gum inflammation, which can reduce strain elsewhere in the body. Even posture and breathing habits can influence tension and headaches over months. This is why health advice can sound boring, yet remain powerful. The exciting part is leverage. When you change one small routine, it can open the door to another because you have more energy and clearer thinking. Compounding works in both directions. The math is always running. The liver can rebuild lost tissue if damage stops in time. After certain injuries, this organ can increase cell division and restore working mass, sometimes astonishingly fast. Surgeons can remove a large portion for a living donor transplant, and the remaining tissue can grow until it meets the body's demands again. That recovery is not a simple rewind. The rebuilt structure is shaped by blood flow, nutrition, and the chemical signals that guide repair. Alcohol, viruses, and some toxins can interrupt the process by keeping damage active, which pushes healing toward scar formation instead of renewal. When the injury pressure lifts, repair programs can reassert themselves. That is one reason early treatment matters so much. It can change the direction of the story. This capacity also shows how health is not only about avoiding harm. It is about giving the body time and conditions to do what it was built to do. Morning light can shift sleep timing, even on cloudy days. Your eyes do more than form pictures. Special light-sensing cells send timing signals to the brain's master clock. Morning light tells that clock, this is daytime, start the countdown toward tonight. That signal can move your sleep schedule earlier, and it can make it easier to feel sleepy at a consistent time. Even through clouds, outdoor light is often far brighter than indoor lighting, which is why stepping outside soon after waking can be powerful. The effect is not just about brightness. The timing matters. Morning light tends to advance the clock, while late evening light tends to delay it. This is part of why screens at night can nudge sleep later, especially when brightness is high. Think of light as a daily reset button. A short, regular dose in the morning can anchor your rhythms, improve alertness, and make sleep feel more predictable. Temperature changes at night help your brain enter deeper sleep stages. As bedtime approaches, your body begins a quiet heat shift. Core temperature naturally drops, and blood flow to the hands and feet can increase to release warmth. That cooling trend supports the transition into deeper sleep, which is when the brain becomes harder to wake and the body focuses on repair. If you feel too hot, sleep can fragment, since the body struggles to complete that temperature drop. Counterintuitively, a warm shower or bath before bed can help some people. It warms the skin, then triggers heat loss afterward, which can lead to a smoother cooling curve. Breathable bedding, a cooler room, and avoiding heavy meals right before sleep can also support the process. This is not only comfort. Temperature is a biological signal. Your brain reads it as a cue for night. When the cue is clear, sleep can deepen, and the next day can feel steadier. Sleep loss can raise appetite hormones and lower satiety signals. When sleep is kept short, hunger chemistry can tilt before you make a single choice. Levels of ghrelin, a hormone that promotes appetite, often rise, while leptin, a signal linked with satiety, can drop. The result is not just feeling hungrier. It can be feeling less satisfied by normal portions. Sleep loss can also impair glucose handling, which can make energy feel unstable and trigger more snacking for quick relief. Many people notice they drift towards salty or sugary foods after a short night, and then feel less control around them. This pattern can accumulate, especially during busy weeks when sleep is repeatedly shortened. The solution is not harsh restraint. It is recognizing the lever. Rest changes the baseline. When you protect sleep, appetite signals become more proportional, cravings soften, and it becomes easier to stop eating when you are comfortably full. Dreams may help practice emotional responses without real-world risk. Dreams can feel strange, yet they may serve a useful purpose. During certain sleep stages, the brain replays fragments of experience and emotion, then remixes them into new scenes. This can resemble a training simulator, where you face fear, loss, or surprise without the real-world consequences. Researchers have linked dreaming, especially during rapid eye movement sleep, with processing emotional memories. People often report that a problem feels less sharp after sleep, even when nothing changed outside. That softening may come from the brain revisiting the feeling while the body remains safe in bed. When nightmares repeat, it can suggest the system is stuck, as in trauma-related sleep disturbance. Therapies that reshape nightmare scripts can help, which hints that dreams are not meaningless noise. They are part of how the brain updates emotional predictions. In the dark theater of sleep, your mind may be rehearsing calm. Naps can sharpen learning, especially for patterns and motor skills. A short nap is not only rest, it can be a reset for memory. After practice, the brain needs time to stabilize what you just learned, whether it is a piano sequence, a new language sound, or a tricky sports move. Sleep spindles, brief bursts of brain activity that appear in lighter sleep, are linked with this consolidation. So is slow-wave sleep, which can help file away information and free up capacity for later learning. That is why some people wake from a nap feeling clearer, not just less tired. The length matters. A brief nap can boost alertness without much grogginess, while a longer nap can include deeper stages and strengthen memory more. Timing matters too. Naps later in the day can steal pressure from nighttime sleep. Used well, a nap becomes a tool. It can turn practice into progress, and it can make effort stick. Bone is living tissue, constantly remodeled by tiny cellular crews. Inside every bone, two teams are always at work. One group breaks down old material, and another lays down new layers with fresh mineral. This is not only maintenance. It is how bones respond to the forces of life. When you lift, jump, or even carry groceries, stress patterns tell bone where strength is needed. When bones are underused, the body can reclaim mineral and structure can thin. This constant rebuilding also helps regulate calcium in the blood, which is essential for nerve signaling and muscle contraction. Healing a fracture is a dramatic example, yet the quieter remodeling is happening every day, even when you feel nothing. Over time, nutrition and hormones shape how well those crews do their work. Bone health is not frozen at adulthood. It is a living negotiation between load, repair, and supply. Muscles release myokines that act like messages to your whole body. When muscles contract, they do more than move joints. They send chemical signals into the bloodstream that can influence organs far away. Some of these signals support healthier metabolism by helping the body handle fuel more smoothly. Others can nudge immune function and inflammation in helpful directions after the workout ends. This is part of why people often feel clearer and steadier after regular activity, even when weight does not change. It is also why strength matters beyond appearance. Muscle is communication tissue. The message is strongest when the work is repeated over time because your body learns that movement is normal. That learning can change how your liver handles fat, how your brain responds to stress, and how your vessels behave under pressure. You can think of exercise as a broadcast. Every contraction sends a note that says, build, adapt, and stay ready. Skin is an immune organ, not just a protective covering. Your skin is a living border that decides what gets in, what stays out, and how loudly to react. It makes antimicrobial compounds, recruits immune cells, and alerts the body when something breaches the surface. When you get a small cut, the first response is fast and local. Cells release signals that call for clotting and cleanup, then coordinate repair. Skin also hosts its own community of microbes that can help crowd out troublemakers. When the barrier dries, cracks, or becomes inflamed, it becomes easier for irritants and pathogens to slip through. That is why conditions like eczema can feel like more than a rash. They can be a barrier failure with immune consequences. Caring for skin can be surprisingly medical. Hydration, gentle cleansing, and protection from harsh sun are not cosmetic extras. They support one of your largest immune front lines. Saliva begins digestion and also defends teeth with minerals. Before food reaches your stomach, your mouth starts the chemistry. Saliva contains enzymes that begin breaking down starches, which is why a cracker can taste faintly sweet after a moment. At the same time, it washes away particles and helps balance acids that would otherwise attack enamel. It carries calcium and phosphate that can reharden microscopic weak spots on teeth after meals. That is a quiet repair cycle that repeats all day. When saliva flow drops, cavities and mouth irritation become more likely. This can happen with dehydration, mouth breathing during sleep, certain medications, or stress. Chewing sugar-free gum can stimulate saliva, and so can sipping water steadily. Your mouth is not only an entry point for eating. It is a busy protective environment with its own built-in maintenance system. Good oral health starts with respecting that invisible rinse and rebuild. Your lungs have their own microbiome, though it stays very sparse. For a long time, lungs were treated as sterile. Now we know that small numbers of microbes can live in the airways, shaped by what you breathe and how well the lungs clear debris. The key difference from the gut is scarcity. The airways are constantly swept by mucus and tiny cilia that move particles upward for removal. That cleaning keeps microbial populations low, and it helps prevent infections from taking hold. When the clearing system is impaired, problems rise. Smoking can damage cilia. Chronic illness can thicken mucus. Pollution can irritate the lining and change local defenses. Even reflux can bring stomach contents upward and alter the airway environment. The lung microbiome is less about abundance and more about balance in a place built for oxygen exchange. Breath is intimate contact with the outside world. Your lungs manage that contact with active housekeeping every minute. Blood is a moving organ, carrying heat, signals, and repair tools. It is easy to think of blood as a simple fluid, yet it behaves like an organ in motion. Red cells deliver oxygen for energy. White cells patrol for threats. Platelets rush to plug leaks. Plasma carries hormones that coordinate appetite, stress, and growth. Blood also moves heat. When you flush red in warmth, vessels widen to shed heat through the skin. When you turn pale in cold, vessels narrow to conserve warmth in the core. Even clotting is a carefully timed story, since it must seal damage without blocking healthy flow. Hydration changes volume, which affects how hard the heart must push. Iron status changes oxygen delivery, which can change stamina and focus. Blood connects every organ to every other organ. It is the body's courier network. When it is healthy, messages arrive on time. When it is strained, the whole system feels it. The spleen can store platelets, then release them in emergencies. Tucked under the ribs, this organ works like a quiet warehouse for parts of your blood. It filters aging red cells, checks the blood for certain microbes, and holds a reserve of platelets. Those platelets matter because they help form clots that stop bleeding. When the body faces sudden stress, contraction signals can push stored platelets back into circulation. It is an emergency boost, like opening a reserve tank. The spleen also participates in immune responses by helping present suspicious material to immune cells, which supports faster recognition of threats. Sometimes people live without a spleen after injury or surgery, yet they need extra protection against certain infections because that filtering role is missing. This makes the spleen easy to overlook until it is gone. Health is full of hidden helpers like this. They do vital work in the background, and they rarely ask for attention. Your lymph system is a second circulation, clearing fluid and debris. Every day, fluid leaks out of tiny blood vessels to bathe your tissues, and most of it must be returned. That return trip is handled by lymph vessels, which collect excess fluid, proteins, and cellular waste, then carry it back toward the bloodstream. Along the way, lymph nodes act like security checkpoints. Immune cells gather there to examine what is being transported, which helps the body respond quickly if a pathogen appears. This is why lymph nodes can swell during infection. They are busy. Lymph flow depends heavily on movement and breathing, since the system lacks a strong central pump like the heart. Muscle contractions squeeze lymph vessels and help move fluid along. That is one reason swelling can worsen with long stillness. The lymph system is drainage, transport, and immune surveillance at once. It is a quiet, engineering marvel. When it runs well, you never notice it. When it struggles, the body feels heavy. The thyroid can nudge metabolism by tiny shifts in hormone output. This small gland in the neck acts like a thermostat for energy use. Its hormones influence how quickly cells turn fuel into heat and work, which affects heart rate, temperature tolerance, digestion speed, and even how alert you feel. A modest change can ripple outward. When output is low, people often feel sluggish, colder than usual, and mentally foggy. When output is high, the body can feel revved, with faster heartbeat, restlessness, and unintended weight loss despite normal eating. Thyroid hormones also support growth and brain development, which is why thyroid health matters profoundly during pregnancy and childhood. The thyroid does not act alone. It listens to signals from the brain, and it relies on iodine from diet to build its hormones. It is a reminder that health can hinge on tiny molecules released in tiny amounts. Small signals can steer big systems. Your brain uses a large share of your daily energy budget. Even when you are lying still, your brain is paying a steady bill. It has to keep billions of cells electrically ready, maintain chemical balances, and run constant background tasks like breathing regulation and temperature control. That work costs energy. For an organ that is only a small fraction of your body weight, it can demand roughly a fifth of your resting fuel. That is why severe drops in blood sugar can feel so dramatic, since the brain depends on a reliable supply. It is also why the brain guards its energy with smart shortcuts. It predicts, it filters, and it automates. When you learn a skill until it feels effortless, you are often reducing how much active control is needed. Focus feels tiring because it is expensive. The brain is not lazy. It is an energy strategist, always choosing what deserves power right now. The heart's rhythm influences emotion through nerve pathways to the brain. Your heart does not only respond to feelings, it helps shape them. With every beat, pressure sensors in your arteries send information upward, and the brain uses that stream to estimate safety, effort, and threat. When the rhythm becomes fast and jagged, the brain may interpret the body as braced for danger, even if nothing is wrong in the room. When the rhythm is steadier, it becomes easier for the brain to label sensations as manageable. This is one reason slow breathing can feel calming. It can smooth the pattern of signals the brain receives. Over time, the flexibility of heart rhythm, often called variability, is linked with resilience under stress. This is not about forcing calm. It is about how body signals guide the brain's story. Emotion is partly a conversation, and the heart gets a strong speaking role in that conversation. The vagus nerve links gut, heart, lungs, and mood in both directions. Imagine a long cable running from brain to belly, branching to the heart and lungs along the way. That cable is the vagus nerve, and it carries messages both directions. It can slow the heart after stress, influence breathing patterns, and affect how the gut moves food forward. It also carries sensory reports upward, including stretch, nausea, and subtle inflammatory signals. That means a troubled stomach can darken mood, and a calmer breathing pattern can ease digestive discomfort. The vagus nerve is even involved in a built-in braking system for inflammation, sometimes described as an inflammatory reflex. This is why practices that emphasize long exhalations, humming, and relaxed swallowing can feel surprisingly regulating for some people. They are not magical tricks. They are ways of nudging a major communication highway, one signal at a time. Pain is a brain-made experience, not a direct reading of damage. Pain is real, yet it is not a simple alarm wire from tissue to mind. It is the brain's best guess about danger, built from nerve signals, memory, attention, and context. That is why you can bump your shin and feel nothing at first, then suddenly hurt once you look down. The brain updates its prediction when it believes the situation is serious. It is also why phantom limb pain can exist after an arm or leg is gone. The brain still holds a map, and the map can misfire. This system is protective, but it can become overprotective. After an injury heals, nerves and brain circuits can stay sensitized, keeping pain loud. Understanding this does not dismiss anyone's suffering. It opens doors. Treatment can involve movement, reassurance, and retraining, not only chasing tissue damage. The goal becomes safety learning, not simply silencing a signal. Your body has internal clocks in many organs, not only the brain. Most people hear about the brain's clock, yet many organs keep their own time. The liver anticipates meals and prepares enzymes. Fat tissue changes how it stores and releases fuel depending on the hour. Immune cells shift activity across the day, which may be one reason some symptoms feel worse at night or early morning. These clocks are coordinated by signals like light exposure, sleep timing, and when you eat. When schedules are steady, the clocks align and the body runs smoothly. When schedules swing, the clocks can drift out of sync, like musicians following different conductors. Shift work can be challenging for this reason. Late-night eating can also confuse metabolic timing, since the gut is receiving food when other organs expect rest. The amazing part is that alignment can improve. Regular sleep, consistent meal timing, and daytime light can help bring the orchestra back into tempo. Your arteries can stiffen or soften, depending on daily habits. Arteries are not rigid pipes. They are living tissue that responds to what flows through them. When the inner lining is supported, it releases signals that help vessels relax and widen, which improves blood flow and lowers pressure. When the lining is stressed by factors like smoking, high blood pressure, or chronically high blood sugar, vessels can become less flexible. That stiffness makes the heart work harder with every beat. The encouraging part is that the system can improve. Regular aerobic activity supports healthier vessel function. Diet patterns that lower sodium and emphasize potassium-rich foods can help pressure trends. Even stress management can matter, since repeated surges in pressure challenge the vessel walls. Health is not only what you eat or how you look. It is also how supple your circulation remains, which shapes energy, brain function, and long-term risk. Loneliness is linked to higher inflammation, even without illness. Human connection is not a luxury feature. It is a biological signal that affects how the body allocates defense. When people feel isolated, studies have found shifts in immune activity that resemble a body preparing for threat, with higher inflammatory signaling over time. This can be adaptive in a harsh environment, since isolation could mean more physical danger. In modern life, it can become a slow background strain. Inflammation is useful for fighting infection and repairing damage, yet it is harmful when it stays elevated without a clear purpose. Loneliness can also disturb sleep and increase stress reactivity, which adds more fuel. The hopeful side is that connection is not only about having many friends. It can be about feeling seen and supported. Volunteering, group classes, and even regular small interactions can help. Health includes the social world, because your body listens to belonging, like it listens to food. Your gut can move food using its own nervous system. Deep in the walls of your digestive tract is a network of neurons that can coordinate motion without waiting for instructions from your brain. It senses stretch, monitors chemical signals, and directs muscles to squeeze in carefully timed waves that push a meal forward. If you have ever felt your stomach flip during stress, that is partly because this system listens closely to emotion and hormones, then changes its rhythm. It can speed up, slow down, or tighten in ways that feel very real. This gut network also talks back to the brain through nerves and chemical messengers, which helps explain why nausea can raise anxiety and why calm can settle the belly. It is not a second brain in the human sense, yet it is a remarkably independent control room. Digestion is choreography, and your gut conducts much of it on its own. Fiber feeds microbes that make compounds your colon can use. Some foods reach the large intestine still mostly intact, and that is where fiber becomes valuable. Your own enzymes cannot fully break it down, so microbes take over, fermenting it into short-chain fatty acids. These compounds can fuel cells in the colon and help support a strong lining, which matters because a stronger lining keeps irritation and unwanted particles from slipping into the bloodstream. Fiber also changes the physical environment of the gut. It can hold water, add bulk, and support smoother movement, which many people recognize as regularity. Different fibers feed different microbes, so variety matters more than chasing one miracle ingredient. Beans, oats, lentils, and many vegetables offer distinct forms. When people increase fiber suddenly, gas can rise at first because the microbes are adapting. A slower increase gives the ecosystem time to reorganize. In that way, fiber is not a supplement. It is an ongoing conversation with the life inside you. Gut bacteria can produce vitamins, including some B vitamins and K. Your body gets nutrients from food, yet some nutrients can also be crafted inside your gut by microbes that live there. Certain bacteria can synthesize vitamin K and several B vitamins, then share them within the intestinal environment. This does not mean you can ignore diet. The amount and usefulness vary between people, and absorption depends on gut health and what else is happening in digestion. Still, it is a striking idea. You are not only eating vitamins, you are hosting a tiny workshop that can make them. This is one reason long courses of antibiotics can sometimes be followed by digestive upset or changes in nutrition status. The microbial community is being thinned, and the internal workshop may run less smoothly for a while. It also helps explain why diverse diets often support health in more ways than we can see. Some benefits arrive indirectly, carried on microbial labor. The stomach protects itself from acid using mucus and rapid renewal. Your stomach can hold acid strong enough to help break down food and kill many microbes, yet it does not normally digest itself. That is because it maintains a protective barrier of mucus and bicarbonate that buffers the acid near the tissue surface. Beneath that, stomach lining cells are replaced quickly, like tiles swapped before cracks become leaks. When this protection is disrupted, irritation and ulcers can follow. One common culprit is infection with Helicobacter pylori, a bacterium that can weaken defenses and inflame the lining. Certain pain medicines, especially frequent use of non-steroidal anti-inflammatory drugs, can also reduce protective factors in some people. The stomach's job is harsh, so it builds redundancy. It makes a dangerous substance, then wraps itself in a shield. Health here is not about eliminating acid. It is about preserving the barrier that keeps acid in its proper place, working for you rather than against you. The pancreas balances blood sugar with two opposing hormone teams. After you eat, sugar enters the bloodstream, and the pancreas acts like a skilled referee. It releases insulin to help move glucose into cells, especially muscle and fat, where it can be used or stored. Between meals, when glucose begins to dip, another signal rises. Glucagon tells the liver to release stored glucose, which keeps your brain supplied and your energy steadier. These two hormones work as a pair, one lowering and one raising, so blood sugar stays within a usable range. When this balance breaks down, the consequences can be slow and serious. In type 1 diabetes, insulin production fails because immune cells attack the insulin-making cells. In type 2 diabetes, cells resist insulin's message, so the pancreas strains to keep up. This system is not only about dessert. It is about survival, since too little glucose can impair the brain, and too much can damage blood vessels over time. The pancreas is a quiet negotiator, adjusting every hour of your life. The gallbladder times bile release to help digest fats efficiently. Bile is made in the liver, yet it is not always needed at full strength. The gallbladder stores and concentrates bile, then releases a timed squeeze when fat enters the small intestine. This release helps break fats into tiny droplets, which makes them easier for digestive enzymes to handle. It is like adding soap to greasy water, letting the fat disperse so it can be processed. When the gallbladder is removed, bile still reaches the intestine, yet it arrives more continuously and less in bursts. Many people do fine, though some notice changes with very fatty meals. Gallstones can form when bile components harden, which can block flow and cause sharp pain after eating. The gallbladder is small, but its timing is elegant. It shows how health often depends on delivery systems, not just ingredients. The right substance, released at the right moment, can change how the whole meal is absorbed. The small intestine has huge surface area folded into tiny villi. If your intestine were a smooth tube, you would not absorb enough to thrive. Instead, the inner surface is folded into ridges, then into finger-like villi, and even smaller microvilli. This creates an enormous area for absorption in a surprisingly compact space. Nutrients can pass through the lining into blood and lymph, guided by transporters that act like selective doors. Some doors carry sugars, others carry amino acids, and fats often take a separate route through the lymph system. This is also why damage to the lining can matter so much. In celiac disease, gluten triggers an immune reaction that can flatten villi, reducing absorption and causing symptoms far beyond the gut. The small intestine is not simply a pipe. It is an interface, a living filter, deciding what becomes you. Every meal is taken apart into parts small enough to cross that border, and the villi are the busy hands doing the work. Your liver filters blood from the gut before it returns to circulation. After nutrients are absorbed, much of the blood leaving the intestines travels first to the liver through a special route called the portal vein. This gives the liver first glance at what you have eaten, including sugars, fats, alcohol, medications, and any toxins that slid through. The liver can store glucose as glycogen, package fats, and modify chemicals so they become safer to use or easier to remove. It also helps handle bacterial fragments that occasionally pass from the gut, reducing the chance that the immune system overreacts. This setup is smart. The gut is the largest entry point for outside material, so the body places a major processing plant directly downstream. It is also why heavy drinking can be so damaging. Alcohol arrives concentrated, and the liver must process it repeatedly. Think of the liver as customs at a busy port. It stamps passports, confiscates contraband, and decides what gets released into the wider body. Hydration affects blood volume, which can alter heart workload quickly. Water is not only about thirst. It helps determine how much fluid is circulating in your blood vessels. When you are dehydrated, blood volume can drop, and the heart may need to beat faster or harder to maintain pressure, especially when you stand up or exercise. This can feel like lightheadedness, a racing pulse, or reduced endurance. Hydration also influences how well you cool yourself through sweat, since sweat draws from body water stores. In hot weather, the strain can rise quickly. On the other hand, drinking far beyond your needs can be risky too, particularly if it dilutes sodium in the blood. Most bodies do best with steady intake, guided by thirst and circumstances like heat, activity, and illness. Foods contribute water as well, especially fruits, soups, and vegetables. Hydration is a moving target, not a strict number. It is one of the fastest levers you can pull to change how your cardiovascular system feels today. Even mild dehydration can worsen headaches and concentration for some people. The brain is sensitive to shifts in fluid balance. When dehydration begins, blood volume can dip and blood flow regulation can change, which may contribute to headaches in susceptible people. You might also feel mentally slowed, with attention slipping more easily. This matters in ordinary situations, like long meetings, travel days, or school mornings when water intake is low. Dehydration can also make fatigue feel heavier, which then makes focus even harder. Many people mistake that feeling for low motivation, then reach for caffeine without addressing the basic need. A simple drink of water can sometimes soften the problem within minutes, especially if the headache is linked to heat or exertion. That said, headaches have many causes, and hydration is not a cure for all of them. Still, it is one of the easiest variables to test. Your body communicates in sensations. Sometimes a headache is also a message about missing fluid, not missing willpower. Your kidneys filter blood all day, then fine-tune what returns to you. Every minute, these two organs receive a huge share of your blood flow, and begin a careful sorting job. Tiny filters let water and small molecules pass into microscopic tubes, while larger proteins and blood cells stay behind. Then comes the real magic. The kidneys decide what to keep, what to release, and what to adjust. They reclaim needed water, return glucose when levels are normal, and balance electrolytes like sodium and potassium so nerves and muscles can function. They also help manage acidity, which matters for enzyme reactions throughout the body. When you are sick, sweating, or eating differently, the kidneys keep recalculating to protect stability. You rarely feel their work, yet you feel the results every time you stand up without dizziness, every time your heartbeat stays steady, and every time your body chemistry stays within its narrow, safe range. Kidney hormones help control blood pressure and signal bone health. Beyond filtering, your kidneys act like endocrine decision makers. When they sense reduced blood flow or low sodium delivery, they release renin, which starts a hormone cascade that can tighten blood vessels and raise pressure. This system is useful during dehydration or blood loss, yet it can become a problem if it stays overactive. The kidneys also release erythropoietin, a hormone that tells bone marrow to make more red blood cells when oxygen delivery is low. That is a direct line between kidney health and stamina. They also help activate vitamin D into a form the body can use, which supports calcium balance and bone maintenance. So a kidney issue can echo into fatigue and bone weakness, not just changes in urine. It is striking how a pair of fist-sized organs can influence pressure in your arteries, oxygen in your blood, and strength in your skeleton through signals you never see. Urine color can hint at hydration, though it is not perfect. Urine is a daily report card from your kidneys, and color is one of the easiest clues. Pale straw often suggests plentiful fluid, while deeper yellow can suggest that the kidneys are conserving water. Yet the story has twists. Certain foods, like beets, can shift color dramatically. Supplements can turn it bright yellow. Some medications can change it too. Even the first urine of the morning is often darker because you have gone hours without drinking. What matters is pattern, not a single glance. If the color stays very dark, or if you notice red, brown, or cloudiness with pain, that can be a reason to seek medical advice. In ordinary life, this simple check can help you notice when you are running low on fluids before thirst becomes loud. It is a small feedback tool that keeps you curious about your own chemistry. Bladder nerves can become more sensitive with frequent urgency patterns. The bladder is a stretch sensor with a strong opinion. As it fills, nerves send signals that rise in intensity until your brain decides it is time. If you repeatedly rush to the bathroom at very small volumes, the system can learn a new normal. The threshold for urgency can drop, and the sensation can arrive earlier and feel more insistent. This can happen during periods of anxiety, after a urinary infection, or when habits form around convenience rather than need. Caffeine can also increase urgency for many people, since it can irritate the bladder and increase urine production. The hopeful part is that the system can relearn. Bladder training uses gradual timing changes to rebuild confidence and raise the volume at which urgency appears. Pelvic floor muscles also matter, since they help control release and signal safety. The bladder is not only plumbing. It is a conversation between nerves, muscles, and learned expectation. Sweat cools you through evaporation, not through dripping alone. Sweat is most effective when it disappears. When liquid on your skin turns into vapor, it steals heat from your body, and that is the cooling. In dry air, evaporation can be fast, so a lighter sweat can cool you well. In humid air, evaporation slows because the air is already loaded with water, so sweat can drip without giving much relief. That is why humid heat can feel heavier and more dangerous. Air movement also matters. A breeze, a fan, or walking speed can carry moist air away from the skin and improve cooling. Clothing can help or hinder, depending on whether it allows airflow and evaporation. This system is one reason heat illness can sneak up. You might be sweating a lot and still overheating if the environment blocks evaporation. Your body is trying to run an air conditioner, and the outside world determines how well it works. Heat acclimation can expand plasma volume and ease strain over time. If you spend repeated days in hot conditions, the body can adapt in ways that make the heat feel less punishing. One early change is an increase in plasma volume, which is the liquid portion of blood. More plasma helps the heart move blood efficiently to the skin for cooling while still supporting muscles and organs. Sweating can also begin earlier and become more effective, with changes in how salty the sweat is. Heart rate during a given workload often drops as the system becomes more efficient. This does not happen instantly. It builds over days, then deepens over a couple of weeks with consistent exposure. It can fade when you return to cool environments. Acclimation is not immunity. Extreme heat can still be dangerous, especially with dehydration, illness, or heavy exertion. Yet it is impressive that your body can tune itself to a climate, adjusting blood, sweat, and cardiovascular control like a living thermostat learning a new setting. Shivering makes heat by tiny muscle contractions you barely notice. When you get cold, your body has a fast emergency plan. It tells muscles to contract in small, rapid bursts, creating heat as a byproduct of activity. You are not choosing to move, yet energy is being burned to defend core temperature. Shivering can start before you feel truly chilled because the brain responds to skin temperature and predicts risk. It can also stop suddenly when you warm up, since it is tightly controlled. This process is effective, yet it is inefficient. It burns fuel quickly and can leave you exhausted if it continues. That is why cold exposure can be surprisingly tiring. Shivering also competes with fine motor control, which is why cold hands fumble with keys and buttons. In severe cold, shivering can fade as energy stores drop and body temperature falls, which is a dangerous sign. Shivering is your body's backup heater, loud and costly, designed for short-term survival. Brown fat can burn fuel to make warmth, especially in cold. Not all body fat is built for storage. Brown fat is packed with mitochondria, the tiny power plants of cells, and it is wired to generate heat on purpose. When activated by cold signals, it can burn fatty acids and glucose to warm the body without the shaking effort of shivering. Babies have more of it, which helps them stay warm before they can regulate temperature well. Adults can still have brown fat in places like the neck and upper chest, though amounts vary widely. Researchers study it because it changes how the body uses energy and handles fuel after meals. Cold exposure can increase its activity, yet the real-world effects on weight are complex and not a simple hack. Still, as a concept, it is amazing. Your body contains tissue whose job is to waste energy, deliberately, to protect temperature. It is like having a small furnace tucked under the skin, waiting for winter cues. Fever can slow microbes while speeding immune reactions in tissues. A fever is not just heat. It is a coordinated shift in set point, driven by immune signals that tell the brain to raise body temperature. Many pathogens reproduce best within a narrow temperature range, so a higher temperature can make the environment less comfortable for them. At the same time, certain immune processes can work more efficiently when warm, including movement of immune cells and some aspects of signaling. That is the potential benefit. The cost is energy. Fever increases metabolic demand, which can feel like exhaustion and body aches. It also increases fluid loss through breathing and sometimes sweating. In most healthy adults, moderate fevers are part of a normal defense response, yet high or prolonged fever can be dangerous, especially in young children, older adults, or people with chronic illness. Treating a fever is often about comfort and safety, not always about stopping an enemy tactic. Fever is the body choosing a hotter battleground and paying for it with fuel and rest. Inflammation is protective until it becomes chronic and misplaced. Inflammation is the body's emergency lighting. It widens blood vessels, brings immune cells to the scene, and helps clear damage after injury or infection. In the short term, it is a powerful repair strategy. The trouble begins when the signal does not shut off, or when it targets the wrong thing. Chronic inflammation can quietly injure blood vessels, alter insulin response, and strain tissues over years. It can be driven by persistent infections, autoimmune conditions, long-term stress, smoking, poor sleep, or excess visceral fat that sends inflammatory signals of its own. The goal is not to erase inflammation, since you need it. The goal is balance and resolution. That means supporting the off switch with sleep, activity, nutrient-dense food, and medical treatment when needed. You can think of inflammation like a fire alarm. You want it to ring when there is smoke. You do not want it blaring all night because the battery is failing. Vaccines train immune memory without the full danger of infection. A vaccine is a rehearsal that skips the worst part of the play. Instead of letting a virus or bacterium run free, it presents your immune system with safe pieces or safe instructions, then invites a practice response. Cells learn what to look for, how to coordinate, and how quickly to mobilize. Some vaccines use weakened germs, some use purified proteins, and some deliver genetic instructions that your cells briefly read. Many include adjuvants that boost the signal, so the lesson sticks. The result is often faster control if the real pathogen arrives, which can reduce severe disease and long-term complications. Protection can fade with time, which is why boosters exist for some infections. When many people are vaccinated, chains of spread can break more easily, helping protect people who cannot respond well. A vaccine is not only personal protection. It can be community architecture. Allergies are immune overreactions, often to harmless proteins. In an allergy, the immune system treats a harmless visitor like an emergency. Pollen, peanuts, or cat dander can trigger a response designed for parasites and dangerous threats. The body releases histamine and other chemicals that widen vessels and tighten airways, which can lead to sneezing, itching, hives, or wheeze. In severe cases, blood pressure can drop quickly and breathing can become difficult, which is why anaphylaxis is a medical emergency. The puzzling part is why allergies develop at all. Genetics play a role, and early life exposures may shape risk, yet no single cause explains every case. Some people become allergic after years of tolerance, while others improve with age. Treatments range from antihistamines to immunotherapy, which carefully retrains responses with tiny, controlled exposures. Allergies show that immunity is powerful, yet it is not always wise. Sometimes protection needs to be taught restraint. Autoimmune disease is mistaken identity, the body targeting its own. Autoimmunity happens when immune cells confuse self for enemy. Instead of attacking a virus, they attack tissues like joints, skin, nerves, or the lining of the gut. The symptoms depend on the target. Some conditions cause swelling and stiffness, others cause rashes, fatigue, or numbness. Many autoimmune diseases wax and wane, with flares that feel unpredictable. The causes are complex. Genes can raise risk, infections can act as triggers, and hormones can influence timing, which is one reason many autoimmune diseases are more common in women. The immune system normally has checks to prevent self-attack, yet those checks can fail. Modern treatments aim to calm the misdirected response without shutting down defense entirely. Researchers are also exploring ways to restore immune tolerance, which means teaching the body to recognize itself again. Autoimmune disease reveals how health depends on accurate recognition, not just strength. Antibodies can mark invaders and also call in other immune helpers. Antibodies are precision tools made by B cells. They can stick to a virus or bacterium like a label that says, "Deal with this now." Some antibodies block pathogens from attaching to your cells, which can stop an infection before it gains momentum. Others tag invaders so immune cells can grab and destroy them more efficiently. Antibodies can also activate a protein cascade called complement, which helps punch holes in some microbes and amplifies cleanup. After infection or vaccination, antibody levels may rise sharply, then settle into a lower baseline. That drop does not always mean loss of protection, because other immune defenses can remain ready. Antibodies are also used in medicine as treatments, including monoclonal antibodies designed to target a specific molecule with high accuracy. In a way, antibodies are both shields and signposts. They defend directly, and they guide the rest of the immune system to the right target. Your skin and gut barriers are immune defenses, not passive walls. A barrier is not just a surface. It is active security. Skin cells produce antimicrobial peptides that can damage microbes on contact. In the gut, a layer of mucus helps separate bacteria from the intestinal lining, while immune cells stand watch just beneath. Tight junctions between cells act like seals, deciding what can pass. When these barriers are healthy, they limit unnecessary immune alarms, which helps prevent chronic inflammation. When barriers are disrupted, the immune system can face a heavier workload. Cracked skin can invite infection. A stressed gut lining can allow more bacterial fragments to cross, which can trigger immune activation in sensitive people. Diet, sleep, stress, infections, and certain medications can all influence barrier integrity. Barrier health is not glamorous, yet it is fundamental. It is the difference between an immune system that responds to real threats and one that is constantly distracted by what should have been kept outside. The microbiome can block pathogens simply by taking up space. In many ecosystems, the easiest way to prevent invaders is to keep every niche occupied. Your gut does something similar. When beneficial microbes are thriving, they compete for nutrients and attachment sites along the intestinal surface. That competition can leave less room for harmful organisms to settle and multiply. Some friendly microbes also produce acids or other compounds that make the environment less welcoming to certain pathogens. This is called colonization resistance, and it helps explain why infections like Clostridioides difficile can appear after antibiotics disrupt normal gut communities. The defense is not a single hero species. It is a crowd effect. Diversity and stability matter. Diet can support this by providing different fibers and plant compounds that feed different microbes. Sleep and stress can also influence gut function, which indirectly affects microbial balance. Health here is not only about killing germs. It is about supporting an ecosystem that keeps trouble from getting a foothold. Some immune cells patrol like police, others build long-term archives. Your immune system has specialists with very different jobs. Neutrophils and macrophages are fast responders that rush to sites of injury or infection, engulfing debris and microbes. They are more like first responders than historians. Other cells focus on lasting strategy. T cells can be trained to recognize a specific threat, then remain ready to respond if it returns. Some become long-lived memory cells that linger in tissues, positioned at likely entry points like the lungs and gut. Dendritic cells act like scouts, collecting evidence and presenting it to T cells so the right response can be formed. This division of labor is why immunity can feel both immediate and lasting. It also explains why some infections are mild on repeat exposure. The body has already assigned the trolls and filed records. When immunity fails, it is often because the coordination breaks down, not because one cell type was weak. Stress can shift immune balance toward inflammation in vulnerable periods. Stress responses are meant to help you survive short threats, yet they can reshape immunity when they persist. Hormones like cortisol and adrenaline can change how immune cells move, what signals they release, and how strongly they react. In brief bursts, this can be useful. It can sharpen vigilance and speed certain defenses. Over long periods, the pattern can tilt toward inflammation, also weakening parts of antiviral defense. That can mean slower recovery, more frequent flare-ups of inflammatory conditions, or stronger reactions to minor irritations. Vulnerable periods include poor sleep, grief, overwork, and chronic conflict. The immune system reads those states as information about danger. Reducing stress is not about pretending life is easy. It is about giving the body clear cues of safety. Regular movement, social support, and predictable rest can help. When stress softens, immune signals often become less reactive. Health improves when the body stops bracing. Exercise can temporarily boost immune surveillance after the workout. After you move, your bloodstream becomes a highway for immune cells. During and shortly after moderate exercise, certain cells increase circulation, which may help the body scan for infected or abnormal cells more efficiently. It is like sending more patrols onto the streets for a limited window. This effect is not the same as being immune to illness, and extreme overtraining without recovery can backfire for some athletes. Intensity and context matter. A brisk walk, a bike ride, or a steady swim can produce a helpful surveillance bump without pushing the body into exhaustion. Exercise also improves circulation in general, which supports how immune cells reach tissues. Over time, people who move regularly tend to have lower chronic inflammation and better metabolic health, which further supports immunity. The key idea is timing. Right after a workout, the immune system is not asleep. It is alert, traveling, and checking. Movement can be a short-term mobilization, followed by longer-term adaptation. Sunlight helps your body make vitamin D, which affects immunity. When ultraviolet B light reaches your skin, it triggers a chemical change that begins vitamin D production. That vitamin D is then converted into an active form your body uses to influence many systems, including immune signaling. Low vitamin D levels are linked with higher risk of certain infections and immune dysregulation, though supplements do not solve every problem, and research is still evolving. Sunlight exposure is a trade-off, since too much raises skin cancer risk and speeds skin aging. Many people aim for short, regular exposure while also using protection during long outdoor time. Latitude, season, skin tone, and clothing all change how much vitamin D you can make. Food sources help too, including fatty fish and fortified products, yet diet alone may not be enough for everyone. Vitamin D is a reminder that health is shaped by environment as well as biology. Light is not only vision, it is chemistry, and the immune system listens. Your eyes blink to reset vision and protect the cornea. Blinking looks simple, yet it is a precision maintenance cycle that runs all day. Each blink spreads a fresh tear film across the cornea, smoothing the optical surface so light can enter cleanly. It also washes away dust, pollen, and tiny irritants before they scratch. Tears carry oils that slow evaporation, water that keeps the surface hydrated, and proteins that help control microbes. When you stare at screens, blink rate often drops, and the tear film can break up. That can leave eyes feeling gritty, tired, or oddly watery as the body tries to compensate. Blinking also has a brain role. It creates brief visual breaks that help the mind stitch perception into a stable scene. You do not notice the flicker because your brain edits it out. Every blink is a small reset, an invisible wipe of the lens that keeps your world clear. Hearing loss can increase cognitive load, making thinking feel harder. When hearing becomes less sharp, the brain often works overtime to fill in missing sound. Instead of receiving clean speech, it receives fragments. Then it must predict what was said using context and memory. That constant guessing can drain mental energy, especially in noisy places like restaurants or busy streets. Many people describe it as fatigue rather than hearing trouble. They feel worn out after conversations, and they may withdraw socially because listening starts to feel like work. Over time, that strain can crowd out attention for other tasks. It can also change mood, since effort and frustration rise together. Hearing aids and assistive devices can reduce that load by delivering clearer input, which gives the brain relief. Protecting hearing matters too, since loud sound damage is cumulative. Hearing is not only about volume, it is about mental bandwidth. When sound becomes clearer, thinking can feel lighter. Smell links strongly to memory and can change appetite quickly. Smell is wired into the brain in a way that makes it feel personal. Odor signals travel to regions involved in emotion and memory, with fewer relay steps than many other senses. That is why a single scent can bring back a childhood kitchen, a hospital corridor, or a certain season with startling speed. Smell also shapes appetite before a bite is taken. The aroma of bread can trigger saliva and anticipation, while the smell of spoiled food can shut appetite down instantly. In modern life, smell is also part of hazard detection. Smoke, gas leaks, and spoiled dairy are often first noticed through scent. When smell is reduced, people may add more salt or sugar to chase flavor, and they may miss early warning cues in the environment. Smell is not a minor sense. It is a shortcut to memory and a fast lever on desire and safety. Taste is partly smell, which is why colds can dull flavor. What you call taste is a duet. Your tongue detects a handful of basic signals like sweet, salty, sour, bitter, and savory, yet much of flavor comes from aromas that rise from the mouth into the nasal passages while you chew. When a cold blocks those passages, the tongue is still working, but the aroma side goes quiet. Food can feel flat, even if it is seasoned well. This also explains why warm foods can taste better when you are sick. Heat releases more aroma molecules, making it easier for whatever airflow you have to carry them upward. It is also why texture becomes more important when smell is reduced. Crunch, creaminess, and temperature can provide interest when flavor fades. Taste is not only on the tongue. It is in the whole route from mouth to nose. When that route is clear, the brain builds a rich flavor picture from tiny chemical hints. Balance uses inner ear sensors, vision, and muscle feedback together. Standing upright is a group project. In your inner ear, fluid-filled canals detect head movement, while tiny organs sense tilt and acceleration. Your eyes provide a steady reference for where the world is. Meanwhile, sensors in muscles and joints report where your limbs are positioned, even with eyes closed. The brain blends these streams to keep you from falling, and it updates the plan many times per second. When one source is disturbed, the system can wobble. A dark room removes visual anchors. An inner ear infection can scramble motion signals. Poor ankle strength can reduce the quality of feedback from the ground. That is why balance can improve with practice. The brain learns to weigh the most reliable signals and ignore the noisy ones. Balance is not a single skill you either have or do not have. It is a constantly updated calculation, and it can be trained. Motion sickness is a sensory mismatch, not simply a weak stomach. Motion sickness often begins in the brain, not the belly. If your eyes say you are still, yet your inner ear says you are moving, the brain faces a conflict. A common example is reading in a moving car. Your inner ear senses turns and stops, yet the page stays stable, and the brain struggles to reconcile the two messages. The result can be nausea, sweating, dizziness, and a heavy, unpleasant fatigue. Evolution offers one theory. In nature, sensory mismatch could suggest poisoning, so nausea may have been a protective response. Practical solutions often work by reducing mismatch. Looking at the horizon gives the eyes motion cues that match the inner ear. Sitting in the front seat can help. Fresh air and steady breathing can reduce the intensity of symptoms. Some medications also damp the signaling pathways involved. Motion sickness is not a character flaw. It is an overactive conflict detector that sometimes misfires. The brain fills blind spots, and you rarely notice the trick. Each of your eyes has a blind spot where the optic nerve exits the retina, and there are no light-sensing cells there. Yet, you do not see a hole in the world. Your brain quietly fills the gap using surrounding patterns, color, and expectation. It is an everyday example of how perception is constructed, not recorded. The brain also smooths other interruptions. When your eyes jump during quick movements called saccades, vision briefly suppresses, and the brain edits the moment so the world feels stable. This editing is usually helpful, yet it means your experience is partly a best guess. That matters for health because attention and stress can change perception. When you are anxious, the brain can prioritize threat cues and fill in uncertainty with danger. The same machinery that hides a blind spot can also amplify worry. Learning this can be comforting. Your mind is not a camera. It is a storyteller, stitching reality into a seamless scene. Migraines involve brain networks, not just blood vessels alone. A migraine is more than a bad headache. It can involve waves of altered brain activity, changes in sensory processing, and shifts in how pain pathways are regulated. Some people experience aura, which can include shimmering lights, blind patches, or tingling sensations before the pain phase. Many become sensitive to light, sound, or certain smells, as if the brain's volume knobs have been turned up too high. Triggers differ widely. For one person, it is irregular sleep. For another, it is missed meals, dehydration, bright glare, hormonal shifts, or certain foods. That variety fits a network condition, since many inputs can push the system toward a tipping point. Treatments also vary. Some aim to stop an attack early, others reduce frequency, and lifestyle patterns often matter alongside medication. Migraines can disrupt work and family life, and they are frequently misunderstood. Seeing them as a brain state helps explain why they can affect vision, mood, and energy, not only pain. Chronic pain can reshape attention, making threats feel louder. When pain persists, the nervous system can start treating it as a constant priority. Attention gets pulled toward the body, scanning for changes and danger. This can make small sensations feel alarming, which increases stress, which can amplify pain again. Over time, the brain can become more skilled at producing pain, the way it becomes skilled at any repeated task. That does not mean the pain is imagined. It means the system has learned a pattern. Chronic pain can also narrow life. People avoid movement, sleep becomes lighter, and social plans shrink, which can worsen mood and sensitivity. Modern pain science often focuses on retraining the system. Gentle graded movement can rebuild confidence. Safer sleep routines can reduce sensitivity. Cognitive and behavioral tools can change how the brain labels signals. Medication can help too, especially during flares. The goal is not to win a battle in one day. The goal is to change the loop so the brain stops treating every sensation as a threat. Aerobic fitness improves how efficiently your cells use oxygen. When you build aerobic fitness, you are not only training your lungs or your heart, you are upgrading the way your cells harvest energy. With regular aerobic work, muscles can increase mitochondria, improve how they use oxygen, and rely less on emergency pathways that burn out quickly. Your heart can pump more blood per beat, which means it can deliver oxygen with less effort at the same pace. Tiny blood vessels in muscle can also become denser, so oxygen has more doorways to enter. The payoff is not limited to sports. Stairs feel easier. Carrying groceries feels less dramatic. Even recovery after stress can improve because the whole system is better at returning to baseline. Aerobic fitness is like raising the efficiency rating of a machine you live inside. You spend less effort to do the same work, and you gain more capacity when life suddenly asks for more. Strength training signals bones to thicken where loads are repeated. Bones pay attention to force. When a muscle pulls hard on bone during resistance work, the tissue senses strain and treats it like a message. Reinforce here. Over time, cells that build bone can lay down more mineral and improve structure in the areas that experience repeated loading. This is why strength work can help protect against fractures later, especially when it includes weight-bearing moves that challenge the hips and spine. It is also why bone loss can accelerate during long periods of inactivity. Without regular load, the body may decide it can afford to reduce investment. Strength training also improves the muscles that catch you when you slip, which matters because many fractures begin with a fall. This is a beautiful loop. Stronger muscles create better loading signals. Better loading signals support stronger bones. Health becomes sturdier, not by accident, but by repeated compensations between force and tissue. Sitting for long stretches can stiffen blood vessels temporarily. When you sit still for a long time, blood flow in the legs slows, and the lining of blood vessels gets less of the frictional stimulus that helps it function well. That lining is meant to sense flow, then release relaxing signals that keep vessels responsive. With prolonged sitting, some studies show a short-term drop in this responsiveness, especially in arteries of the lower body. It is like letting a hinge go unused, then finding it squeaks when you finally move. The good news is that this effect is reversible. Standing, walking, or even doing brief calf raises can restore flow and remind vessels how to flex. This matters because modern life often stacks long sitting sessions on top of each other, at work, in cars, and at home. The body adapts to what it repeats. Breaking stillness is a small act that keeps your circulation practicing its natural elasticity. Short walking breaks can reduce post-meal glucose spikes. After a meal, your blood sugar rises as nutrients enter the bloodstream, and the shape of that rise can matter for long-term metabolic strain. Research has found that breaking up sitting with brief, light walking can flatten the post-meal curve compared with staying seated. The effect is especially relevant for people who are older, sedentary, or insulin resistant, where post-meal peaks can be higher and longer. What makes this so practical is the dose. These are not workouts. They are small interruptions, a few minutes at a time, repeated. Many people now use continuous glucose monitors to see the curve in real time, and it can be eye-opening to watch a tiny walk change the graph. This turns abstract advice into immediate feedback. It also shifts the story of exercise. Movement is not only about burning calories later. It can be about guiding what happens in the hours after you eat, when your body is deciding where to send incoming fuel. Stretching can change tolerance to sensation, not just muscle length. People often think stretching works because it lengthens muscle like taffy. In many cases, the bigger change is in the nervous system. Stretching can teach your brain that a certain range of motion is safe, which can raise the threshold at which a stretch feels threatening. That is why consistent stretching can increase flexibility even when actual tissue length changes only modestly. It is partly a lesson in sensation. Slow breathing and gradual pressure can reduce the protective reflex that tightens muscle when it feels at risk. This is also why forcing a stretch can backfire. If the nervous system senses danger, it may clamp down harder. Stretching becomes most useful when it is steady and specific, aimed at movement you actually need, like hips for walking or shoulders for reaching overhead. Flexibility is not only geometry. It is trust between brain and body, built a little at a time. Balance practice trains reflexes that can prevent falls later. Balance is a skill, and skills improve with practice. When you challenge balance, your brain updates how it coordinates ankle, hip, and trunk responses, and it learns how to correct wobble faster. These corrections happen before conscious thought, which is why practice matters. You are training reflexes, not giving yourself a lecture. Simple drills can be powerful. Standing on one leg while brushing your teeth, turning the head while walking, stepping over small obstacles. Tai Chi is a classic example, since it builds controlled weight shifts and awareness of foot placement. Balance practice also strengthens smaller stabilizing muscles, which helps joints feel more reliable. This becomes more important with age, when reaction time and vision can change. The goal is not to become fearless. The goal is to become recoverable. A stumble is less likely to become a fall when your body has rehearsed the save 1,000 times in calm conditions. High-intensity intervals can improve fitness in surprisingly little time. Intervals work because they ask your body to switch gears. A brief burst near your limit forces the heart, lungs, and muscles to deliver and use oxygen at a high rate. Then recovery teaches the system to clear byproducts and reset quickly. Repeating that pattern can improve aerobic capacity and efficiency with less total training time than steady workouts, though it is not better for every goal or every body. The intensity can be hard on joints and motivation if it is done too aggressively, so the smart version is scaled. Intervals can be fast walking uphill, cycling with short surges, or swimming with quicker lengths. Many people do well with a simple ratio, like 1 minute challenging and 2 minutes easy, repeated a few times. What makes intervals exciting is that they turn fitness into a conversation with limits. You touch the edge, you back off, and over weeks, the edge moves. Nature exposure can lower stress markers in some people. Many people notice a shift in mood when they spend time in green space, and research suggests measurable changes can accompany that feeling. Stress markers like cortisol can drop, heart rate can settle, and attention can recover after mental fatigue. One reason may be sensory load. Natural scenes often have patterns that are complex yet not demanding, which gives the brain a chance to rest from constant alarms. Another reason is movement. Walking outdoors often includes gentle variation, small climbs, uneven ground, and wider breathing. Social factors can help too, since parks and trails invite connection without the pressure of conversation. Nature is not a cure for serious illness. It can be a meaningful support. Even small doses can matter, like a lunch break under trees or a few minutes looking at a patch of sky. It is a reminder that health is shaped by environment. Your nervous system responds to the world you place it in. Breathing slowly can reduce carbon dioxide swings and calm the body. Breathing is not only about oxygen. It is also about carbon dioxide, which helps regulate blood acidity and influences how the brain interprets breathlessness. When breathing becomes fast and shallow, carbon dioxide can drop too low, which can trigger tingling, dizziness, chest tightness, and a feeling of panic. The body can misread those sensations as danger, then breathe even faster, and the loop intensifies. Slower breathing, especially with a longer exhale, can stabilize carbon dioxide levels and reduce that spiral. It also gives airway muscles time to relax and can reduce the sensation of air hunger. This is why breathing drills can help during anxiety, and why some people feel steadier during asthma management when they focus on controlled exhalation alongside medical care. Breath is a dial you can turn in real time. You are adjusting chemistry with each cycle, and the brain listens closely to that chemistry. Mindfulness can change how the brain predicts and labels sensations. Your brain is always predicting what a sensation means. A flutter in the chest can be excitement or threat. A tight stomach can be hunger or worry. Mindfulness practice trains you to notice sensations earlier and to label them with more precision and less panic. Instead of instantly escalating into a story, you stay with the raw data. Warmth, pressure, movement. This can reduce secondary stress, which often adds fuel to the original sensation. Brain imaging studies suggest mindfulness can alter activity in networks linked with rumination and self-referential thinking, while strengthening control and attention systems. That does not mean the mind becomes blank. It means you gain a little space between sensation and reaction. Over time, this can change habit loops, since many habits begin with an uncomfortable feeling that begs for quick relief. Mindfulness is not about being calm all the time. It is about becoming more accurate. When you name experience clearly, the body often stops shouting to be heard. Social connection predicts health outcomes as strongly as some risk factors. A supportive social life is not just pleasant. It can shape how long and how well people live. Large studies have linked stronger relationships with lower risk of early death, with effects comparable to some familiar health factors. Connection can change the body in several ways. It can buffer stress responses, which helps keep blood pressure and inflammatory signaling from staying elevated. It can also change behavior, since people often eat, move, and sleep differently when they feel supported. Even small interactions can matter, like being greeted by name or having someone who would notice if you disappeared for a day. Connection also affects recovery. People are more likely to seek care earlier, finish treatment, and keep appointments when they do not feel alone. Health is often framed as a personal project, yet the body is social. It listens to belonging like it listens to food, and it responds accordingly. Chronic loneliness can disturb sleep, which then worsens mood. Loneliness is not only a feeling. It can change the way the brain scans for safety. When people feel isolated, the nervous system may stay slightly more alert at night, as if it expects the world to be less protected. That can make sleep lighter and more fragmented, with more awakenings that are easy to forget in the morning. The next day, that poorer sleep can intensify irritability and sadness, and it can reduce motivation to reach out. Then the cycle tightens. This loop matters because sleep supports emotion regulation. With less restorative sleep, the brain's threat filters become sharper, and neutral moments can feel more negative. The hopeful part is that the cycle can be interrupted from either direction. Improving sleep routines can soften the mood drop. Increasing meaningful contact, even one regular weekly activity, can reduce nighttime vigilance. Loneliness often sounds like an emotional issue, yet it can begin reshaping health through sleep. Laughter can change stress hormones and shift pain perception briefly. Laughter is a whole body event. Breathing changes, facial muscles contract, and the heart rate often rises then settles. In the brain, laughter can activate reward pathways and release natural pain-dampening chemicals, which is why a hard laugh can make discomfort feel farther away for a while. It can also reduce stress hormone levels in some situations, especially when laughter comes with social bonding rather than forced cheer. Even anticipation can matter. Looking forward to something funny can change tension before the punchline arrives. This does not mean laughter cures disease, and it is not a command you can always obey. Yet it is a powerful state shift. It can interrupt rumination, relax muscle-holding patterns, and make connection easier. Humor also changes attention. When you are laughing, the mind is not rehearsing worst-case scenarios. For a moment, the body is living in a different chemistry, and that chemistry can feel like relief. Grief can affect immunity, making infections more likely for a time. Grief is a stressor that touches every system. During bereavement, many people sleep poorly, eat irregularly, and move less, and those changes alone can weaken defenses. On top of that, grief can intensify stress signaling, which can shift immune function in measurable ways. Research has linked bereavement with higher risk of illness in the months after a major loss. The body is not failing. It is allocating resources to a prolonged crisis state, and that can leave fewer resources for fighting pathogens. Grief can also increase inflammation, which may worsen existing conditions. This is one reason practical support matters so much after loss. Meals delivered, walks with a friend, and help with paperwork are not just kindness. They are health protection. Grief is not something to fix quickly. It is something to carry, and the body carries it too. Being cared for during grief can reduce the biological cost of that carrying. Trauma can imprint on the body, altering threat detection systems. After trauma, the body can learn that danger arrives without warning. The brain regions that detect threat can become more sensitive, and stress responses can trigger faster, even in safe settings. This can show up as jumpiness, racing heart, muscle tension, and sleep disrupted by nightmares or sudden awakenings. The body may also avoid sensations that resemble the trauma, like certain smells, tones of voice, or crowded spaces. These reactions are not weakness. They are survival learning that has been turned up too high. Over time, the system can be retrained. Trauma-focused therapies help the brain refile the memory as past, not present. Breathwork, movement, and grounding skills can help the nervous system learn safer patterns. Supportive relationships also matter, since trust teaches the body that connection is not a threat. Trauma can leave a physical signature, yet the body remains changeable. The imprint can fade when safety becomes consistent, and when the nervous system is given new experiences to learn from. Placebo and nocebo effects show expectations can shape symptoms. Expectation is like a lens the brain uses to interpret body signals. If you expect relief, pain signals can be turned down through internal pathways that release the body's own soothing chemicals. If you expect harm, the same system can turn sensations up, producing real side effects even from an inert pill. This is the nocebo effect, and it is one reason frightening medical information can sometimes worsen symptoms. Clinicians work around these effects because they are powerful. Good bedside manner, clear explanations, and trust can improve outcomes, not by deception, but by reducing threat and uncertainty. The brain is always predicting. It predicts what a medicine will do, what a procedure will feel like, and what a symptom means. Those predictions influence nausea, itch, fatigue, and pain. None of this makes symptoms imaginary. It shows that treatment is not only chemistry, it is also context, meaning, and the brain's interpretation of what is happening inside you. Habit loops rely on cues and rewards more than willpower alone. A habit is often a shortcut, not a choice made from scratch each time. The brain links a cue to an action, then to a reward, and over repetition, the sequence becomes automatic. The cue might be time of day, stress, boredom, or walking past a certain shelf. The reward might be comfort, stimulation, relief, or a sense of completion. Once the loop is formed, the brain can start the behavior before you consciously decide, which is why habits can feel like they run on rails. Changing a habit usually works better when you keep the cue and change the response, while still delivering a reward. For example, the cue of afternoon fatigue could lead to a short walk instead of scrolling, while the reward becomes alertness and a mental reset. Environment matters too. If the cue is visible and convenient, the loop strengthens. Habit change becomes less about moral strength and more about redesigning cues and rewards. Willpower varies with sleep, stress, and blood sugar stability. Self-control is not a fixed personality trait. It is a brain function that depends on resources. When you are sleep-deprived, the prefrontal systems involved in planning and inhibition tend to work less effectively, while reward signals can feel louder. Under stress, the brain may prioritize immediate relief, which makes long-term goals harder to hold. Blood sugar swings can add another challenge, since low energy states can increase irritability and urgency, and the mind starts looking for fast fuel or quick comfort. This is why just try harder often fails. The conditions are wrong. People tend to make their best decisions when they are rested, fed, and not overloaded. That suggests a useful strategy. Plan hard choices for times when your brain is resourced. Reduce friction for good habits and increase friction for impulsive ones. Willpower becomes less like a heroic battle and more like wise scheduling. Protect sleep, keep meals steady, and you often find that self-control feels less like wrestling and more like steering. Purpose in life is linked to better long-term health metrics. A sense of purpose can act like an internal compass. Studies have linked stronger purpose with lower risk of early death and better outcomes across several health measures. The pathways are partly behavioral. People with purpose may be more likely to move, to keep medical appointments, and to maintain routines that protect sleep. Yet purpose may also change stress physiology. When life feels meaningful, setbacks can feel more manageable, which can reduce chronic stress load. Purpose does not need to be grand. It can be caring for family, building a craft, serving a community, or learning something that matters to you. It can also change over time. Retirement, illness, or loss can shift it, and that shift can be disorienting. Rebuilding purpose can be a health intervention, not just a life project. When you wake up with a reason, your body often behaves differently through the day. It prepares, it invests, and it recovers with more consistency. Health behaviors spread through networks. Friends can influence habits. Humans learn by watching. In social groups, norms about food, movement, and rest spread quietly. If your friends take evening walks, walking starts to feel normal. If your workplace celebrates staying late, sleep can start to feel optional. Research on social networks suggests that behaviors like smoking and weight change can cluster in groups over time, influenced by shared environments and social imitation. This can work for you or against you. A supportive group can make healthy choices easier by reducing friction and adding accountability. A high-stress group can normalize skipping meals and living on caffeine. The influence is often subtle. It shows up in what you talk about, what you invite each other to do, and what you praise. This means you can shape your health by shaping your surroundings. Joining a class, finding a walking buddy, or building a family routine can shift the baseline. Health is not only personal discipline, it is also social gravity. Antibiotics can save lives, yet they can disrupt gut ecosystems. These medicines are one of the great turning points in human health. A bacterial pneumonia that once killed quickly can become treatable within days. A deep wound infection can be stopped before it reaches the blood. Yet antibiotics do not only hit the culprit. Many also strike helpful microbes that live in your gut and that can change digestion, immunity, and comfort for a while. Some people notice diarrhea, bloating, or new food sensitivities after a course. In certain cases, the disruption creates an opening for tough bacteria like Clostridioides difficile to overgrow, which can cause severe illness. This is why clinicians aim for the narrowest effective drug, for the shortest effective time. It is also why finishing or not finishing a course is a medical decision, not a folk rule. Antibiotics are powerful tools. Like all powerful tools, they work best when used with precision and respect. Drug metabolism varies by genetics, liver health, and other medications. Two people can take the same dose and experience very different effects. Your liver uses enzyme systems to break down drugs, and those enzymes are influenced by genetics. Some people process a medicine quickly, so levels drop sooner. Others process it slowly, so the same dose lingers longer and side effects become more likely. Age, alcohol use, and liver disease can shift this too. Then there are drug interactions. One medication can block an enzyme that another medication depends on, which can unexpectedly raise levels. Grapefruit is a famous example for certain drugs, since it can interfere with metabolism pathways and change how much reaches the bloodstream. Even herbal supplements can matter, since some can speed up or slow down breakdown. This is why medication lists are so important at appointments. It is also why the same prescription can feel perfect for one person and miserable for another. Your body is a chemistry lab with unique settings. Blood pressure can look normal, yet still hide risk over years. A single reading is a snapshot, not a biography. Blood pressure changes with stress, sleep, caffeine, pain, and even the timing of your last meal. Some people have white coat hypertension, where clinic anxiety pushes numbers up. Others have masked hypertension, where readings look fine in the clinic but run high at home, especially during busy days. Nighttime blood pressure patterns matter too. Many people should dip lower during sleep. When that dip is missing, risk can rise even if daytime readings seem acceptable. That is why home monitoring and ambulatory monitors can be so valuable. They reveal the true rhythm of pressure across real life. Over time, even mildly elevated pressure can quietly stress arteries, the heart, and the kidneys. The danger is not drama. The danger is slow wear. Blood pressure management is often about seeing the pattern early, then nudging it down with steady habits and, when needed, medication. Many diseases begin silently, long before symptoms appear. The body is good at compensating, and that can hide trouble. Blood vessels can narrow gradually while you still feel fine. The liver can tolerate strain while quietly building fat. Some cancers grow slowly with no pain at first. Type 2 diabetes can develop while energy seems normal until the system finally cannot keep up. This silent phase is not a failure of awareness. It is how biology works. Symptoms often appear when a system has used up its buffer. That is why routine checkups can matter, even when you feel healthy. Lab tests can reveal rising cholesterol, changing kidney function, or creeping blood sugar before damage accumulates. Screening can catch cancers earlier, when treatment tends to be simpler. The goal is not to live in fear of hidden illness. The goal is to treat health like maintenance, not emergency repair. Your body whispers long before it screams. Listening early can change the entire story. Prevention works best when it feels boring, steady, and repeatable. The most powerful health habits rarely look dramatic. They look like a person who sleeps at a similar time most nights. They look like meals with vegetables showing up again and again. They look like walking, stretching, and lifting done in small doses that do not require heroism. This is boring in the way brushing teeth is boring. It is also why it works. The body adapts to what it sees often. Extreme changes can backfire because they are hard to sustain, and the rebound can erase progress. Steady prevention builds resilience slowly. It lowers the odds of injury, reduces strain on metabolism, and keeps mood more stable. It also creates momentum. When one routine is easy, another routine becomes possible. Prevention is not glamorous, yet it is deeply hopeful. It means the future is not only something that happens to you, it is something you influence with ordinary choices that become automatic. Screening tests catch patterns early when treatments can be gentler. Screening is not about finding problems to worry about. It is about finding problems while they are small. A colonoscopy can remove a polyp before it becomes cancer. A Pap test can detect changes before cervical cancer develops. Mammography can find breast cancer earlier when surgery may be smaller and outcomes often improve. Blood tests can flag kidney strain, anemia, or rising blood sugar before symptoms appear. Not every screening is right for every person. Age, family history, and individual risk matter. And some tests carry false positives that create stress and follow-up procedures. That is why guidelines exist, and why shared decision-making with a clinician is valuable. The core idea is timing. When a disease is caught early, the body has more reserve, and the medical options are broader. Screening is a way of buying time. Time often translates into simpler treatment and better recovery. Vaccination rates protect communities through herd effects when high enough. Infectious diseases spread through networks. When many people are immune, a pathogen meets dead ends more often, and chains of transmission break. That reduces outbreaks, and it also protects people who cannot respond well to vaccines, like some infants, people on certain immune-suppressing treatments, and those with specific medical conditions. The exact level of coverage needed varies by disease, since some pathogens spread more easily than others. Measles, for example, requires very high coverage because it is highly contagious. Herd effects do not mean risk disappears. They mean risk is lowered for everyone, especially the most vulnerable. This is one of the rare health tools where your choice can protect a stranger you will never meet. It is public health in the most literal sense. Communities become safer when immunity is widely shared. Vaccines are not only personal armor. They are a collective firewall that works best when many people contribute. Air pollution can inflame lungs, then ripple into heart risk. When you breathe polluted air, tiny particles and gases irritate the airway lining. That local irritation can trigger inflammation and oxidative stress, and the effects do not always stay in the lungs. Inflammation signals can spread through the bloodstream, and some particles may even enter circulation. This can influence blood vessel function, raise blood pressure, and increase the risk of heart attacks and strokes over time. The risk is not equal for everyone. Children, older adults, pregnant people, and those with asthma or heart disease are often more affected. The pollution source matters too. Wildfire smoke, traffic exhaust, and indoor cooking smoke each have different mixtures. Protection can be practical. Following air quality alerts, using indoor filtration, avoiding heavy outdoor exertion on bad days, and reducing indoor smoke exposure can lower dose. Air is an environmental risk factor you cannot fully control, yet you can reduce your exposure. Health is not only inside you, it is also in what surrounds you. Ultra-processed diets can crowd out fiber that microbes depend on. Ultra-processed foods can be convenient and tasty, yet they often displace whole foods that feed your gut ecosystem. When meals become mostly refined starches, added sugars, and low-fiber fats, microbes that thrive on plant fibers can decline. That can reduce production of helpful fermentation compounds in the colon and may weaken the gut lining over time. Ultra-processed foods can also be engineered for fast eating, which makes it easier to overshoot fullness signals. Some contain emulsifiers and additives that researchers are still studying for their effects on gut function and inflammation. This is not about banning all packaged foods. It is about proportion. If most meals come from boxes and wrappers, you may be starving the microbial community that supports digestion and immunity. A simple fix is addition, not restriction. Add beans to soups. Add oats to breakfast. Add a handful of nuts or fruit to a snack. Feed yourself, and you feed the ecosystem that feeds you back. The best diet pattern is one you can sustain for years. Nutrition advice often fails because it treats eating like a short project. Bodies do not respond to one perfect week. They respond to months and years of patterns. A sustainable diet is one you can follow through holidays, stress, travel, and busy seasons without feeling trapped. That usually means it includes foods you genuinely enjoy, and it fits your culture, budget, and schedule. Research on long-lived populations often points to common themes rather than strict rules. More plants, more minimally processed foods, enough protein, reasonable portions, consistent meal timing. It also means flexibility. A pattern that forbids entire food groups may work short-term, then collapse under real-life pressure. A pattern that allows room for celebration can last. The healthiest diet is not the strictest. It is the one that keeps you nourished and satisfied while quietly protecting your heart, metabolism, and gut over time. Consistency beats intensity in the long run. The brain can rewire after injury, called neuroplasticity. After a stroke or a head injury, the brain is not locked into defeat. Neurons can strengthen surviving pathways, recruit neighboring regions, and build new connections that take over lost functions. This is why rehabilitation is not just practice. It is biology responding to repetition. When someone relearns speech or regains a steadier hand, the brain is adjusting its wiring based on what is used most. The process is often slow, and it can be uneven, with sudden leaps after weeks of frustration. Early training can matter because the brain is especially responsive during certain recovery windows, yet improvement can continue long after the first months. Sleep, nutrition, mood, and safe movement all influence how well the brain can adapt. Neuroplasticity is not only a recovery concept. It is proof that change is built into the nervous system and that health can include rebuilding, not only preventing damage. New habits can form faster when tied to existing routines. A new habit needs a reliable starting point. If you attach it to something you already do, the cue becomes automatic. You brush your teeth, then you do 2 minutes of stretching. You start the kettle, then you refill your water bottle. This works because the brain loves chains. Once the first link happens, the next link is easier to trigger. It also reduces decision fatigue, since you are not searching the day for the perfect moment. The routine creates the moment for you. The most effective pairings are specific and frictionless, and they fit the same place and time each day. If the link is too ambitious, the chain snaps. So the smartest start is often smaller than you think. Consistency builds identity. Soon it feels strange not to do the new behavior, because the old routine now expects it. Habit stacking is not motivation. It is architecture, built from cues you already trust. Your body adapts to training, but also adapts to inactivity. The body is a master of efficiency, which is both a gift and a warning. When you train, it upgrades what you ask for. Muscles learn to recruit fibers more effectively, tendons stiffen to transmit force, and the heart and lungs coordinate better for the demands you repeat. When you stop moving, the same intelligence goes the other direction. The body reduces what seems unnecessary. Endurance fades, strength declines, and joints can feel less comfortable at extremes because they are no longer visiting those ranges. This is not punishment. It is budgeting. The body does not want to maintain expensive capacity it never uses. The hopeful part is how quickly the curve can turn again. A small return to activity can restore confidence in movement, and it can restart the signals that say, keep this tissue strong. Health is not a static achievement. It is a relationship with demand, and the body becomes what it practices. Muscle is an endocrine organ, sending signals far beyond movement. When you contract muscle, you trigger a chemical broadcast. Muscle cells release signaling molecules that travel through blood and influence distant tissues. Some of these signals support healthier metabolism by encouraging better fuel handling after meals. Others influence inflammation and immune behavior, which may help explain why regular activity is linked with lower chronic inflammatory load. Muscle also communicates with the brain. Many people notice improved mood and clearer thinking after consistent training, and signaling molecules are part of that story alongside blood flow and stress reduction. This is why muscle loss with age matters beyond strength. Less muscle can mean fewer beneficial signals, not just less ability to lift. Building and maintaining muscle becomes a form of internal communication support. You are not only training for performance, you are shaping what your body says to itself each day. Movement becomes messaging, and the message can reach almost everywhere. Sleep and exercise together often outperform either one alone. Sleep and exercise are partners, not competitors. Exercise can deepen sleep pressure, making it easier to fall asleep and increasing restorative stages for many people. Sleep then improves how well you adapt to training, since repair, hormone regulation, and memory consolidation happen at night. If you train hard but sleep poorly, gains can stall, injury risk can rise, and motivation can collapse. If you sleep well but never move, sleep alone cannot build strength, balance, and cardiovascular resilience. Together, they create a loop. Movement makes sleep more stable. Sleep makes movement feel easier and more rewarding. Timing matters. Some people sleep better with morning training, while others do well in late afternoon. Very intense exercise late at night can disrupt sleep for some, though not all. The takeaway is not perfection. It is pairing. When you protect sleep and keep moving, each one multiplies the benefit of the other, and health becomes a system that helps itself. Small improvements in walking speed predict lower mortality risk. Walking speed can look like a simple trait, yet it reflects how many systems are working together. To walk briskly, you need leg strength, balance, joint comfort, cardiovascular support, and enough brain coordination to place each step confidently. Researchers have found that faster usual walking speed is associated with lower risk of death in older adults, and it can serve as a practical marker of overall function. The key is not turning life into a test. The key is noticing that walking is a whole body report. If your pace improves over months, it may mean your heart is handling effort better, your legs are stronger, and your nervous system is coordinating more efficiently. Even small gains can matter because they suggest reserve. Reserve is what protects you during illness, travel stress, or a bad week of sleep. A brisk walk is not only movement. It is a sign of capacity, and capacity is one of the best health assets you can build. Oral health links to whole body inflammation more than most people realize. Your mouth is a busy border where bacteria and tissue meet every day. When gums are inflamed, the barrier becomes easier to disturb, and immune signals can stay activated. Chronic gum disease has been associated with higher systemic inflammation, and researchers study links with conditions like cardiovascular disease and diabetes. The relationship is complex, and it does not mean brushing your teeth prevents every illness. It does mean the mouth is not separate from the body. Bleeding gums are a sign of inflammation, not a normal feature of brushing. Plaque is a biofilm, which means bacteria are organized and protected, and that makes them harder to remove without consistent care. Flossing or interdental cleaning disrupts that film where a toothbrush cannot reach. Dental visits can catch problems early when treatment is simpler. Oral health is a daily practice with whole-body consequences. It is one of the most overlooked places where prevention is concrete, quick, and surprisingly powerful. Hearing your own heartbeat can change anxiety, depending on context. Your brain constantly interprets internal signals, including the rhythm of your heart. For some people, noticing a strong heartbeat feels reassuring, like proof of life and strength. For others, it can trigger worry, especially if they have had panic attacks or health anxiety. The same sensation can be read as danger or normal, depending on past experiences and current stress. This is called interoception, which is your sense of the body's internal state. When interoception becomes overly vigilant, harmless sensations can become alarms, and the body responds with more adrenaline, which makes the heartbeat louder, and the loop grows. Training can change this. Practices that pair a steady breath with noticing sensations can teach the brain a calmer interpretation. Medical reassurance matters too, because true heart issues should not be ignored. The fascinating part is the meaning layer. Your heart is beating either way. The mind decides what the beat implies, and that decision can shape anxiety in real time. Health is systems thinking. Tiny changes echo across organs. Health is not a row of separate buttons. It is a network where one shift can ripple outward. A steadier sleep schedule can improve appetite regulation, which can change food choices, which can influence gut comfort, which can affect mood and energy. A short daily walk can ease joint stiffness, which can make movement feel safer, which can lower stress, which can improve sleep. These are not poetic chains. They are practical feedback loops. This is why single solutions often disappoint. The body rarely changes through one lever alone. It changes through a set of small levers that support each other. Systems thinking also explains why setbacks happen. A stressful week can disrupt sleep, then cravings rise, then movement drops, then confidence falls. The fix is rarely punishment. It is restoring one stabilizing node, like bedtime, hydration, or a short walk. When one node steadies, others follow. Health becomes less about fixing one organ and more about guiding the network. The goal is not perfection, it is resilience and recovery. Perfect health is a fantasy because life is not stable. People get sick, travel, lose sleep, grieve, and face unexpected stress. Resilience is the ability to bend without breaking, and recovery is the ability to return. That means building habits that can survive messy days. It means knowing your early warning signs, like irritability, cravings, or poor sleep, and responding with repair rather than self-blame. It also means planning for setbacks as part of the system. A resilient plan includes simple meals, a default walking route, and a bedtime routine that can travel with you. Recovery includes rest, hydration, and returning to basics instead of trying to make up for lost time with extremes. The body responds well to consistency, yet it also needs forgiveness. When you focus on resilience, you stop measuring yourself by flawless streaks. You measure yourself by how quickly you return to your supports and how kindly you rebuild after disruption. As we come to the end of our journey through health, notice what we have really been listening to. Not a single system, but a whole living network, always adjusting, always learning. We drifted from immune memory to the chemistry of movement. We followed sleep as it shapes appetite and repair. We visited the gut and its crowded ecosystem. We listened to the heart and the nerves that carry messages between organs. We watched the body manage heat and cold, and we noticed how stress can speed some processes while slowing others. We stepped into the senses, into balance, pain, and perception, and we saw how the brain builds your experience from signals and predictions. We explored the power of community, of purpose, and of small routines that quietly compound. And we ended with a simple idea that can hold everything together. The goal is not perfection. It is resilience and recovery. If you enjoyed this calm exploration, you can support the channel by liking, subscribing, or leaving a comment about what surprised you most. And if you are still awake, there will be another video waiting on your screen, ready to carry you a little farther into the night. For now, let your attention soften. Unclench your jaw. Let your shoulders drop away from your ears. Feel the weight of your body being held, without effort. Let your breathing find a slow, easy rhythm, in and out, like a tide that does not need you to steer it. You have done enough for today. Your body knows how to continue its quiet work. Sleep well, and good night.